Now, folks, one of the best ways to measure water and electrolyte balance is a very, very simple way. We check our wee-wee. So what we've got here is we've got the idea of urine colour. And I'm sure this is something you probably do to some degree. It's kind of, I won't say it's natural, but it's kind of, like you have to learn it and understand why. But we do it because this is what we call a dynamic measure. In other words, it changes at all times. It continually changes and kind of the readings update. So we've got like an ongoing measure of one's urine colour every time, of course, we do a wee. And generally, it's quite convenient to use this method. I'll put in brackets here the kind of idea of it's mostly convenient, and I can't just do a wee everywhere, obviously, but we want to just understand this. So, okay, we've got two factors to consider with this. So 2 factors I want you to be aware of. So 2 factors. First of all is the amount of your urine. Okay, so first of all, are you not weeing a great deal, or are you weeing a great deal? That's going to give you an indication as to your relative hydration levels. But the second point is the colour, and that's where we're going to spend a little bit of time just to quickly understand this. You can see that as one's wee progresses from kind of straw colour to, my God, almost browny red over here, this is showing gradual evidence of dehydration. Okay, so that's, of course, a general guide, but we want to understand why is this actually occurring. And we need to remember the role of ADH. Okay, so remind yourself, ADH is antidiuretic hormone, and what happens is when electrolyte concentrations are increasing, in other words, when we're losing fluids, what will happen is that ADH will be released by the pituitary gland in greater amounts, and it will stimulate the kidneys to retain fluids. Okay, so let's say we are exercising. The pituitary gland, why is that hard to say? The pituitary gland will release more ADH. It will cause the kidneys to retain more fluids. And then, of course, what happens is we've effectively got less fluid in our urine, and we've got a higher concentration of, I'm just going to put other stuff. Now, of course, this could be all kinds of different things, other stuff. But because of that, the actual kind of coloration becomes darker. Why? Because there's less solution for the solute to be dissolved into, and that, of course, is why that darker colour actually occurs. So how do we address that? Well, broadly speaking, if you find your wee up at this kind of level, for example, what do? Is we drink water. It could be sort of reduce exercise conditions as well, get out of hot conditions, but we drink water, and that, of course, is going to bring that concentration down, and of course we're going to get less ADH produced by the pituitary gland, and therefore fluids are going to be released more, meaning this concentration now is more concentrated solution. There's more solute in there. Okay, now then, that's not our only measure. We also want to be thinking about body weight, and this is a really, really simple concept, but one that's got some really intriguing details about it, and I'll get to those hopefully quite quickly. Now, first of all, the idea here is that if you lose weight, so weight loss during exercise, let's imagine you're running a 10k race and it's really hot conditions, that is being caused by dehydration. So the cause of weight loss, is dehydration when we're talking about something that's happening during one's performance. And of course, in order to measure this, you could do sort of you get on the scales pre-exercise and post-exercise and see the differences. The scales need to be quite accurate unless you're doing some really significant. Now, it has been argued, or let me put it this way, some argue for a 2% threshold. And what this means is, RESHOLD, if what happens here, the idea is that if anyone goes over 2%, more than 2% decrease in body weight, then what we're going to find is that this is detrimental to performance. Okay, so if 2% is lost or greater, that is going to cause a detrimental performance. And this led in 2007 for hydration guidelines to be written for athletes in 2007, and it was based on this 2% of total body weight threshold. So basically, if you go and do your 10k run in hot conditions and you lose greater than 2%, it's pretty likely these guidelines argue that you're performance is going to decrease beyond what it should decrease over the course of the race. However, there are some issues with these studies. These studies were based on what we call sweat-induced conditions. In other words, participants in the studies were put into very hot, humid conditions, such as like sauna type conditions, and of course they sweated very, very, very rapidly in that case. So because of that, that is not necessarily the same as the conditions that athletes will be doing, I don't know, a London Marathon in, for example. Okay, so the validity of those results may be questions. And specifically, and you might find this really interesting, specifically, there was a study done after the guidelines were published in 2009, which I know seems ages ago to you, but it's really recent to me. And it was done around the Dubai Marathon. Of course, Dubai, very, very warm country in the Middle East, in the Gulf of Arabia. And of course, what happened in this Dubai Marathon 2009 is that they worked with highly, and I've always got to check the spelling of this name, Gebre Selassie, very famous athlete, by the way. When I was growing up, was one of the absolute legends of distance running. And what they found was that he, despite winning this race, he lost 9.8% of his body weight. Okay, 9.8% of his body weight. And now that challenges the 2% threshold, because this winning performance came from this significantly greater weight loss from that position. So there's an interesting sort of consideration. Now, to finish this off, guys, I want to talk to you but probably the most technical of these. We can look at osmolarity. Now, this is a relatively complex sort of concept, but I want to try and simplify it if I can. The idea of this is that we can measure not how much electrolyte we have in our body, but the concentration of our electrolyte. Now, we've already touched on this in things like we talked about dehydration, hypo and hypernatremia. But if we consider, especially for electrolytes, if we consider that the way to measure this is the relationship between the number of electrolytes, potassium, sodium, for example, in relation to how much water is in the body, that gives us a concentration. And effectively, what this is giving us is electrolyte concentration. And we want that to be at appropriate levels to prevent either hyper or hyponatremia. Okay, now we've got some measures. Traditionally, the measure of this was an OSM. These are what are called osmoles. We measure in osmoles. But with this reading, we don't do that. With this reading, we measure in osmoles per litre. Why? Because it is a relative indicator. How many osmoles, molecules of electrolyte, are there in relation to litres of fluid in the body? And this is what we might find in measurements like these. Let me just drag down slightly. We might find one of two scenarios, and you will know both of these if you've done my previous tutorials. We will either have a high concentration, so lots of electrolyte, lots of potassium, lots of sodium, and this is going to lead during exercise to hypernatremia. Now remind yourself of what we mean by that. This is when someone experiences the loss of water only. So what we're finding here is that water levels are going down, so this is water, but our electrolyte levels are kind of either going down more slowly or they're not going down. Okay, so what we're finding here is that water is being lost in a greater rate than electrolytes, meaning our osmoles per litre go up because the litres are fewer. But also we could be talking about a low concentration scenario. Now this is where we want to be thinking now about our hyponatremia. Hyponatremia. God, it's a long word, isn't it? Hyponatremia. Now this is where a person will lose both. So during exercise, we might lose both our water and our electrolytes. But rather than taking an isotonic drink, for example, which would replace both, we only replace water. So we replace water, we do not replace electrolytes. And of course, what's going to happen there is we're going to have a low concentration because we have not replaced these, but we have replaced the water. And that, of course, is going to decrease the concentration of the solute in the solution. Thanks for listening.